So in this question, we've been told that George works in a shoe shop on Saturdays, and on average, he serves 8 customers each hour. We're asked to find the probability that in a given hour on a Saturday, George will serve more than 10 customers. So firstly, let's identify the distribution. I hope you can recognize this is a Poisson distribution. We've been given an average rate for, in this case, the customers that George serves, and we've been given a time interval. So a rate of 8 in a time interval of an hour. This is the Poisson distribution where lambda is going to equal 8. I'm just going to state that. So x follows a Poisson 8 per hour. And we've been asked to find the probability that George will serve more than 10 customers. And I'm going to rewrite that as the probability that x is greater than 10 equals the probability x is greater than or equal to 11. I always want to include a value I'm going to use in my calculation. I'm going to type into the calculator, and 11 is that value. Remember, your calculator is not set up for greater than or equals to probabilities, so I need to do 1 minus the probability x is less than or equal to 10. Okay. In our calculators, that's a PCD function, 0, 10, and 8. So that gets us a probability of 0.1841. That's the probability that George serves more than 10 customers. In part B, we're asked to find the probability that in a given 3-hour interval on a Saturday, George serves exactly 24 customers. First thing to do is to scale up this distribution. So if it's 8 per hour, it will be 24 per 3-hour interval. That was just 8 times 3. And you'll notice I've given this the subscript of 1. So this is x1. It's related to x, but it's not the same. The probability that x1 equals 24. So on average it's 24. It's the probability of getting exactly 24. In our calculators for the PCD function, the minimum and maximum are both 24, and the mean or the average or the lambda value is also 24. So into our calculator, and we get an answer of 0.0812. Part C of the question now says that the manager of the shop claims that George has recently become complacent and he's serving fewer customers than he used to. During a given 1-hour period on a particular Saturday shift, George serves 4 customers. We're asked to test at the 10% level of significance whether there's evidence to support the manager's claim that George is serving fewer customers. Okay, so this is a hypothesis test, and we'll do all the usual things. We're going to start with the null and the alternate hypothesis. H0, lambda equals 8. He's serving at his usual rate. And H1, this is the manager's claim that actually his rate has gone down. He's serving fewer customers. We've been set a 10% level of significance this time. So 10%. During this observation period, the manager saw that George served 4 customers. That's less than expected, but is it significantly less? So the expected is 8, 4's over here. That's less than expected, but is it significantly less? We're going to calculate the probability of being in this shaded area. If that probability is below the significance level, we have a significant result. The probability that x is less than or equal to 4. We can do PCD, 0, 4, and 8. And the probability comes out to be 0.0996. Now, this is smaller than our 10% significance level, so yes, we do have a significant result. With a significant result, we conclude that we reject H0, and we'll have to say there is enough evidence to suggest that George is indeed serving fewer customers. George has become complacent. That's what the evidence is suggesting, and it supports the manager's claim.